It has been quite a long time since I last published content to the channel, and that is due to various things happening in my life here in Poland. Thanks for sticking with the channel through everything. Your patience, your kindness, and your support truly mean a lot to me, and I really appreciate you all for not giving up on it. A big thank you as well to the channel members, and welcome to the new ones joining in. Your support genuinely helps me put more time and effort into creating better content. And if you're new here, thank you so much for tuning in. Glad to have you. Feel free to subscribe and join the family. Alright, with that said, let's jump into today's topic, C#. C# was created by Anders Hillsberg at Microsoft and officially released in 2002 alongside the first version of the .NET framework. From the beginning, the goal of C# was really ambitious. It was to combine the power of C++, the productivity of Java, and the safety of managed runtime environments into a modern language designed for large-scale software development. So, to build and run applications in C#, you will need to install the .NET SDK, the software development kit. That is very, very important. It's the complete toolkit that's used to build .NET application. Any kind of application, whether TUI, CLI, GUI, a server, whatever you want to create, you will need for that .NET SDK. Alright, so we're going to download it and install it on our machine. So some of these tools include the C# compiler, obviously, the .NET CLI, and that's going to be your friend while you're working with C#. Alright, I'm going to show you now how it works in the terminal. Anything you need to do, basically you will need for that .NET, this word here, .NET. It's basically a CLI tool that is broader and bigger than a package manager like NPM or pip or cargo. It's wider than that. It creates your project, it builds it, it debugs it, it even deploys it, so it does a lot of things. Basically everything you need to do in the terminal you're working with C#, you're going to use for that .NET CLI tool. Also, it has project templates, package management systems, build tools, and the runtime itself. And I've created specifically for you guys a gist for all of the commands that you will need for .NET. So I'm going to leave the link for that in the description below. One important thing to note here is that C# was heavily inspired by languages like C++, Java, and Delphi, which is an IDE and programming language based on Object Pascal, and later functional programming concepts as well. Early versions of the language focused on clean object-oriented programming, automatic memory management through the .NET runtime, and a developer-friendly syntax that felt powerful without becoming overly complicated. And for many developers, coming from C, C++, or Java, C# quickly became attractive because it offered high-level productivity while still feeling structured and performant. And during the late 2000s and throughout the 2010s, C# evolved faster than almost any mainstream language. Microsoft continuously introduced features that solved real-world engineering problems while keeping the language readable and maintainable. And one major milestone was generics. Generics actually allowed the developers to write reusable type-safe code without sacrificing performance. Then came the LINQ, LINQ, which stands for Language Integrated Query. This is one of C#'s most innovative features, enabling you, the developer, to query collections, databases, APIs, XMLs, everything actually, using expressive syntax directly inside the code itself. And I'm going to give you a few examples on that while we're coding our program. Later, C# introduced async await, which completely transformed programming. I don't know if you know or not, but C# actually was the first language ever to introduce the async await code, asynchronous programming. So basically, the async await syntax or asynchronous programming allows you to write non-blocking code for networking, file systems, APIs, or UI applications. At the same time, the .NET ecosystem itself evolved dramatically. Originally, it was tied mostly to Windows, as it's Microsoft, right? So .NET eventually became fully open source and cross-platform through the .NET Core. Then in 2020, Microsoft unified the ecosystem into modern .NET. That's why I told you it was called before .NET Core. From 2020 onward, it's called .NET. And I don't want this introduction to be that long, so I'm going to wrap it up here. All in all, C# remains one of the world's most widely used programming languages. It powers enterprise systems, web APIs, cloud infrastructure, desktop software, developer tools, financial systems, video games, game development with Unity, of course, and cross-platform applications used by millions and millions of people every day. Alright, now let's go ahead and download and install the .NET SDK. Alright, so I'm going to leave the link in the description below. You can go ahead and visit that. You will install the last version of .NET SDK, .NET 10.0. You're going just simply to click on that .NET SDK x64 and you're going to download it, install it, and to make sure that .NET is properly installed on your machine, you would want to open your terminal, whatever your terminal is, and you would want to check the .NET version. So .NET -- version, hit enter, and you have here .NET 10.0.102. That is the last version of .NET. So it's very important to know the commands attached to .NET, the supplementary commands based on .NET. .NET version, to check out the version. We can also do .NET info, right? That's going to display the installed SDK, right? The runtimes, the operating system, the architecture, the environment path, you know, everything. Also, you can list the installed SDK. So you can do .NET list SDKs. It's going to list the installed SDK. You can also list the installed runtime by doing .NET list runtimes. Runtimes. To create a project, you can do .NET new console, and yeah, you can give it a name, or you can just, you know, do it inside your project. So let me create a test folder, cd to that, and we'll do here .NET new console, right? Let's list. You'll find here one folder and two files. So one folder called obj, the program.cs or C# extension, and test.cs proj. Okay, usually we use Visual Studio, okay, Microsoft Visual Studio, but Visual Studio Code is much lighter version of that, so I'm going to work with Visual Studio Code. You can go to Visual Studio Code website and download the version based on your operating system, whether it's macOS, Linux, or Windows. So now that we know that we have our .NET properly installed, we can actually create a project. So let me use the .NET new console command, follow that new folder, and I'm gonna call it Hello World. All right, let's do Hello World, and let's go to Hello World, right? And we have those components, a folder and two files. Let's open this with Visual Studio Code using code dot, and it's going to open Visual Studio Code for us in the current path. Let me just bring this over here. All right. And you can see here that we have our program.cs here. If you will click that, you have your default program, which is a simple program to print to the console, Hello World, the default application. All right. So to run this application, we'll open the integrated terminal. Let me just make sure that I'm in the current path, which is the Hello World. Okay, awesome. And if you would do .NET run, it's going to compile, and it's going to print for us a beautiful Hello World. All right, so that's the application that we're going to be coding today. It's a simple CLI tool, a library manager. So what it does, it adds books, it views the books, it searches the books. You can borrow a book, you can return a book, you can save data to a JSON file. So we're going to work with not database, but data persistence system using JSON file. So we will use serialization to serialize C# objects to JSON elements, and deserialization from JSON to C# objects to list everything to the console. So we're going to have fun today. And finally, you can exit the program. All right, so let's view the books that we have. We have It for Stephen King and 1984 for George Orwell. All right, let's add another one. Let's say, for instance, The Call of Cthulhu. The author is, of course, H.P. Lovecraft. The year, I really don't know. Maybe, I don't know. 25, whatever. book added. All right, so now we can view the books and we will find that that book has been added, and it's also of course added to the JSON file. Now if you will exit the program by typing 0, and if you run it again using .NET run and the name of the file, and you want to display the books or view the books, you will find that the Call of Cthulhu is still there, right? We can search for books. We can do Stephen King, for example, and we have one book for Stephen King, which is it. We can borrow, okay, so I've hit enter by mistake, and that is invalid option. That's also error handling mechanism. We're going to see that, but if you want to borrow a book, you can hit 4, and you can borrow the first book, you have a message telling you that the book is borrowed successfully. Press enter to continue, and if you will check view books, you still have all of the books here, and if you will display the books again, you will find that it is being borrowed while the other 2 books are available to be borrowed. All right, we can return the book, and that the ID of that book was 1. All right, if we will display again, you will find that Stephen King book is available to be borrowed. All right, and we can save the data. We have a confirmation message that the data is saved, and then we can exit the program. All right, guys, so before we code the application, which will be in a follow-up video tutorial only dedicated for the app, just I want to discover with you C# in this in the rest of the video. Okay, we're going to do that in the .NET script, in the C# REPL. We have different .NET commands, but we need only .NET script to write interactively C# code and see what will happen. In my opinion, this is an excellent and fun way to explore a language, right? Whether it's Python, whether it's Node.js, whether it's Haskell. Today we're doing it with C#. So what you will need to do is to type .NET script, and you're going to type commands and see the results directly. So yeah, the first thing we can do is obviously you can do console.writeLine, writeLine like so, and we can you can print things, right? So you can print things to the console. You can put the semicolon or without the semicolon in the .NET script. It's going to accept it normally. It's no problem. And you can obviously do console.writeLine numbers, right? You can do you can make like this, for instance. To declare a variable in C#, you will start by the data type. So let's say we want a string, for instance. So we're going to say string and the name. So the name is equal to Bob, for example, right? So you just need to do like this. Because we have declared variable, we haven't actually asked the console to print something or to execute something, so we needed to enter the semicolon. And as you haven't done it and pressed enter, so the asterisk is telling you to continue. Okay, continue the expression, right? So if you do name, that is Bob, and obviously you can do like this, name. Right, so that's what I told you, how you can actually you can print variables, no problem. Strings, numbers, variables, Boolean types, whatever. Okay, and as we are talking about variables, I told you that we can do string name equal to Bob. We can do int number equal to 150. Again, I've fallen the same mistake, right? So that is a number, that is a name, right? And you could do console.writeLines instead of name, we'll do number. And for example, you can do int num1 equal to 100 and int num2 equal to 550, right? Then you can say console.writeLine. You can print you can print num1 plus num2, right? 650. Or you can say simply num1 plus num2. You're going to get the same. And of course, we can have floating point numbers, decimal numbers. And for that, we have double. right? So double is the decimal point numbers here, and we can have pi, for instance, 3.14159. Okay, so that is pi. So double stores decimal numbers, but also we have, for precision, we have decimal. Okay, you have date type decimal. Decimal is used for money and finance and prices, stuff like that, for precision, for accuracy. Let's say, for instance, 50.12, right? If you will leave it like that, you're going to get an error, right? Because it tells you here, literal of type double cannot be implicitly converted to type decimal. Use an M suffix to create a literal of this type. So actually, without it, C# assumes the number is a double. However, you have written decimal. So to differentiate, you will need to add M at the end, right? And you will have your price. And of course, you can add your price plus your num1, 150.12. You can add another number, 700.12. All right? So these are the data types that we have so far: int, double, string, int, double, and decimal. Okay? We have also Boolean values, of course, Boolean for true or false. To declare a Boolean value, you will type bool like so, and let's say is online, and we can say here true. So is online in this case is true. And of course, Boolean is used for conditions. If you want to create some flags for checkup, for validation, permissions, stuff like this. Okay. We have characters as well. We have char, so use keyword char, and we can have here char grade A. Okay, so that is a char grade A. But be careful, this is in single quotes and not double quotes. In double quotes, you can say like this: string grade 1 equal to A, like so. Okay, so you have grade and you have grade 1. See the difference? This is a character and this is a string. Now, there's something we call type inference, and type inference simply means that you don't need to tell the compiler that this is an int or this is a string, right, or this is a double, for example. It's going to automatically assume that this is a string or double or decimal, right? So instead of doing that, you would use the keyword var, variable, right? So var, let's say a language, for instance, that is C#, okay? So this is a language, and we can also do for the integer, we can do here 12. Okay, so var allows the compiler to infer the type automatically. You don't need to state that explicitly to the compiler that this is an int or string, double, boolean, and so on. Okay, be careful that the compiler looks at the value and determines the type. But C# is still strongly typed, which means that strong typing means variable still have fixed types. You cannot do this later. You cannot take a version, for instance, and do like this. You're going to get an error. It tells you here that cannot implicitly convert string to int. You cannot change that. However, you can change the value itself. Okay, you can overwrite the value. You can do var version equal to hi instead of hello. And the compiler is going to accept it. Normally is going to substitute the last value you assign to this version variable. The hello doesn't exist anymore in the memory. So again, just to show you that you cannot do like this. You cannot take version now and make 150. You're going to have now the opposite. It cannot implicitly convert type int to string, right? We have done the opposite here just to show you different scenarios. Also, we have string interpolation. What does that mean? Let's have a variable called framework that is the .NET, and let's have the version, and that is 9. Oops. Okay, so we have here framework, we have the version, right? Sounds good. Now, if I want to type console or type to the console, console.writeLine, I want to substitute, have placeholders for both, and substitute the framework and version for whatever framework and version hard-coded in my program. I want to print that. Simply, like in any programming language, like in JavaScript, for example, it's very close. Also Python, that's also very close to what we're doing here. So you will need to use the $sign. $sign, open double quotes, curly brace, framework, shut the curly brace, version, and whatever the version that we have hard coded here, shut this, and shut this, right? So we have now .NET version 9. Okay, this is the string interpolation, and what permits the string interpolation actually is this $sign. This is very important, and expressions inside the curly braces are evaluated directly inside the string. Okay, so any expression in programming is code that produces a value. So an expression in programming is code that produces a value. Okay, if you do 10 plus 5, this is an expression. Version here, this is an expression, right? If you have, for example, int x equal to 5, if you would do x multiplied by x, this is an expression, right? So all of these produce values, hence they're called expressions. Also, let me show you data formatting. So I want to format to write to the console today is what day, what the day, I mean Monday, Tuesday, whatever, the month, the day, and the year. So how to do that? Console.writeLine, and we're going to use the $sign again. We're going to say here today is, and we'll do like this, date time dot now, and we need 4 D's for the day itself. We need 3 capital M's for the month. 2 D's for the day itself, and 4 Y's for, because we need 4 Y's because that's 2026, 4 characters. Okay, close the curly brace, close the double quotes, parentheses. Let's just have, and let's take a look. Today is Wednesday, June the 3rd, 2026. Right. That is June the 3rd, 2026. It is 9:52 at night. Right, so now let me show you also the operators very quickly. We have obviously arithmetic operators. We can do addition, we can do subtraction, we can do multiplication, right? And we can do also division. That's fine. And also we can have the modulus, the remaining. So if you will say 10 modulus 3, that is 1. Why? Simply because if you would do division, if you would take 10, you divide it by 3, that is 3, right? 3 multiplied by 3, that's 9. And if you subtract that, you will have 1 remainder. That is the one which is here, right? So that's the modulo. Also, we have comparison operators. So 10 is bigger than 5. This is truthy. 10 is less than 5. This is falsy. This is comparison, to compare 2 different numbers, right? You can do, for instance, x is equal to 100 and y is equal to 200. Oh, right, I should do like this, int y equal to 200. So now we have x, now we have y, and if you would do x is equal to, is it equal to, you're comparing both, of course you're going to get a false, right? Also, take a look at this. If you would say, for instance, string num is equal to 100, and if you would do int numx, for instance, okay, equal to 100 as well. So both values are the same, right? No, not right. If you do num is equal to numx, you're going absolutely to get an error, because it tells you here that operator equal cannot be applied to operands of type string and int. You cannot do this. You're going to get an error, right? Also, there is the not equal to. So 10 is not equal to 5, and that is truthy. 10 is not equal to 10, that is falsy. If we would take num again, not equal to numx, we're going to get again an error, because the operator not equal to cannot be applied to operands type string and int. The same exact thing. The last category of operators that I have for you is the logical operators, and, or, and not. And is written this way, right? And true and true, that is going to get us true, right? True and false, that is a falsy statement. Sorry. Right? That is falsy. So that means that both sides here must be true. Must be true. This and that. If for example, you're trying to check out if the weather is good and there are tickets. In this case, we will go to, I don't know, New York. True and true, that's true. True and false, that's false. Also, we have true or false, right? So true or false, that will give us true. True or true, that is that is also true. And finally, not true, that's false, and not false is true. So the and, that means that both conditions must be met, or means that at least one side must be true. And the not means that, you know, it flips a Boolean value. If it's not true, that's false. If it's not false, it's true, right? It's as simple as that. Right, now let's check out quickly the conditions. The conditions, like in any programming language, you know, they allow the code to make decisions. So let's say that if a person has 18 years old or older, he's an adult, he's allowed to smoke or to drive or to do whatever, right? Or to drink alcohol or whatever. Okay, so let's check out very quickly in C# how to do that. Int age equal to 20. We have the age equal to 20, and then I want to check if age is more than or equal to 18. That means that he is an adult, right? So how to write that? Simply open here curly braces, like in most of the C-based programming languages, you use curly braces like that. And we'll write here adult, and we will just shut the curly brace, and we are good to go. That is adult, right? So this is only if. Now we can also use if else. So if X, do 1, else do 2, for example, right? So again, I'm going to do declare variable temperature 15 degrees Celsius. It's raining outside, by the way. So I'm sitting here on my desk and doing this tutorial for you guys while it's raining. It's awesome. If temperature is more than 20, I'm going to do here console.writeLine, and we're going to say that is warm, right? Oops, I shouldn't actually do that. Okay, let's repeat this again. Else, I will open again curly brace, and we can hit enter. We can write on a separate line, no problem. And we'll say here that this is cold, right? Makes sense. Like this. And when I will hit enter, what do we expect? We have the temperature 15, and we are checking if the temperature is more than 20. So in this case, it's not more than 20, it's less than 20. So that's going to give us cold, Right. Now let's check out loops quickly, guys. And we have different ways to do a loop. We have for loop, for each loop, while loop. Okay. So I'm going to start by the for loop. So we'll do like this: for, and we'll open parentheses, int I equal to 0. In this case, unless I is less than 5, I want to increment the I, right? This is the shorthand. That's actually I equal to I plus 1, but that is the shorthand to do it, right? So I plus plus, right? We will shut that. Now I will open curly braces. We'll do here console.writeLine, and we will print the iterator. That is a problem in the REPL or in in any form of REPL that you need to repeat the whole code. And you will get here from 0 to 4, 0, 1, 2, 3, 4. So a for loop is commonly used in this case when we know how many times we want to repeat something. Let me also show you the for each loop. So we have also something called for each, which is very similar to the for loop. So suppose that we have a list, so var names equal to, and I'm going to use keyword new. So new is used to instantiate an object from a certain class. The class we have is list. We want a list of strings. All right. So we can say here Alice, Mina, Charlie. We have now names list. To print all of the names, we need to loop over that list. And for this, we will need to use the for each loop. So we'll say here for each var name in names. And we are going to console.writeLine, and we're going to print every name in that list. So there you go. Alice, Mina, Charlie. We can have this list, which is a collection that stores multiple values. But the most important thing to note here is that list, an array, and a dictionary all fall under the umbrella of collection. Right, now let's check out the last loop, which is the while loop. And the while loop, of course, keeps running as long as the condition remains true. For example, if I have a counter and that starts from 0 initially, I want to use the while loop to check out a certain condition. This condition is the count is less than 3. So as long as count is less than 3, I want to print all of the numbers, the iterator, the count. Okay, so we expect to have 0, 1, and 2. So to do that, simply we're going to console.writeLine, and we're going to print the count, and of course don't forget to increment the count, and just don't forget the semicolon, and just make like this, curly brace with a semicolon, and we expect to have 0, 1, and 2 because this is 0 base index. So we have 0, 1, and 2 as expected. Now let's check out the methods together, the methods or the functions. So let's say that we want to create a method that adds 2 numbers. We can do that simply by saying int add, because we want that function, that method, to have a result as an integer. So int add, and we have 2 different arguments here, int a and int b, right? Those are the inputs for my method. And what I want to do is to return a plus b. And that would tell me that the semicolon after the method or accessor block is not valid. Then, if you will pass to your method 5 and 150, you're going to get 155. Now let's say that we want to create a method to calculate the square of a number, right? So square, and we want only one number here, right? That's our input because that's going to be multiplied by itself. So we're going to say here, take that x and multiply it by itself, right? If you would take the square and you will pass 100, you're going to get 10,000. Try this with any other number. Aha, that's an error because we have defined it to be int, not double. If you want to create this square number of a double, you should do here double, right? And we can call this square. Let's do square double, something like this. And that is not an int, but also double y, okay? And we're going to return y multiplied by itself. And we are good to go. If you will take the SD and you pass 25.21, for instance, that's going to, calculate properly with the decimal numbers. It's going to take 25.21 multiplied by itself to give us the result, 635 point, that number you see on the screen. Let me show you something called expression bodied methods. These are so cool, they're very minimal, and I love minimalism. We can write the square number method on one line only, okay? So if you do int square, exactly like we have done before, we want to pass x as an input, and then we're going to use that arrow like this, equal sign, then greater than. Okay, so this is an arrow, x multiplied by x. You're going exactly to get the same result. This, by the way, is called the lambda arrow. So it creates a shorter method syntax. Now let's talk very quickly about other collections like arrays, for example. So an array stores multiple values of the same type, exactly the same type. You cannot mix types in an array. You cannot do integers, strings, and blah, blah, blah inside one array. It's unacceptable, okay? So again, if you want to have an array of integer numbers, you're going to start by int, open, close, square brackets like so, and then the name of your variable, of your array, right? And then you will open and close curly braces, and you will have your numbers, okay? So this is an array of integers, of numbers, and you can see that it has actually written the number of the elements inside your array, depending upon the data type that you define. So let's say string, for example, string names or countries. We can have here USA, we can have here Canada, France, and if you do like this, countries, you're going to see that we have string of 3 elements, USA, Canada, and France. So square brackets always indicate an array. Let's see the lists. So let's see actually how the lists are depicted in C#. Let me just make it like this. All right, lists. So of course, lists are dynamic collections. Unlike arrays, lists can grow and shrink, right? So if you want a list, you can do it simply. We have seen that before, but let me repeat that again. Var of numbers, and we're going to have with the new keyword to instantiate numbers object from the list class. That list of, it's int generic list, so it's of data type integer, and open close curly braces, and you will have 1, 2, 3 like so. Oops. Okay, list of 1, 2, 3. I don't want to talk about classes and objects now. This is object-oriented programming. I'm going to talk about OOP in C# in a bit. But for the moment, just bear with me. Let's take this numbers list and append to it or add to it a number. So you have a method called add, and we can add here number 4, for example. So expect that the numbers will expand from 1 to 3 to 1, 2, 3, 4. Right? So add inserts a new item into the list. I'm not going to. This is a very short course for C#. I'm just showing you what you can actually do. And along the way, while we are programming our application in the next video, we're going to see more things along the way. All right, so let me show you how a dictionary is depicted in C#, how we can create a dictionary in C#. Let's say that we want a user dictionary. He has a name, role, phone number, email, address, all of that. So we have a user that is equal to new, again, the keyword new, and that is used to instantiate an object, which is the user object from the dictionary class. And we said that every dictionary has a key value pair, and for both key and value, we will have both of them string data types. Okay, so both of them, both the key and the value, have string or string data types. And as we said, that every dictionary has key value pair. It can be one key value pair or multiple key value pairs, like in our case, for instance. And we want them to have both string data types, okay? Both of them. The key is a string and the value is a string. Now, open curly braces, and then we will have our key first, and that key is equal to a certain value. The key is written inside those square brackets inside double quotes, because that's a string and we can have a name, and the name in this case we can have Brad, for instance, right? So that's the first key value pair. We can also have another key value pair, which is the profession, and the profession of Brad is a programmer. We can also have his email address, and the email address in this case we have here brad@mail.xyz. This is not a real email address. Okay, and just we shut that, and just don't put a comma at the last key value pair in your dictionary. And please don't forget to add the double quotes at the end of profession, otherwise you're going to get an error like I have. Right, if you will hit enter, now we have our user dictionary. But this is not a very good representation of our user dictionary. And of course, you can access all of the attributes inside your dictionary. So you can say, for instance, user, and you want to check out the name, can do so. You want to check out his email, right? You can check out also his profession, programmer. Now let's leave dictionaries and go and check out the hash sets. So what a hash set is the equivalent of sets in Python. It automatically removes any duplicates, any redundant information in your hash set. They're going to be removed automatically. So let's say that we want to have a new hash set of data type string, and let's call this one languages. Let's open curly braces and let's have different languages. So let's have C#, let's have C, let's have Rust, let's have C++, let's have C# again, let's have Odin, let's have Haskell, let's have Rust again, and let's have C++ again. Let's shut that and let's check out. These are our languages hash set. If you will print that, you're going to have that we have a count of 6, not 9, because we have what? Originally we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So from 9 elements to 6 elements. So you see that the hash set automatically removed any redundant information in our hash set. And that's exactly the same idea in Python. It's called sets in Python's case. Right, so that's as far as hash set in C#. Now let me talk in brief about LINQ. LINQ stands for Language Integrated Query. It allows us to query and transform collections using very clean syntax. Think about it, it's very similar to SQL style data operations. Let me give you a few examples. Let's say, for instance, that we want to do some filtering on some data. And in our case, the data is a range of numbers from 1 to 10. So let's have a range of numbers using the keyword enumerable dot range, and that is going to be from 1 to 10. Okay, these are the numbers stored inside numbers from 1 to 10. Okay, now I want to filter numbers. I want to get the evens, actually, the even numbers, any number that's divided by 2 to give me a 0 remainder. In other words, an even number, not an odd number. So to do that, I'm going to take the numbers and I'm going to filter this using the keyword where. And if you're okay, or if you know the basics of SQL, you know that where filters and checks where what? Where x returns x modulo 2 is equal to 0. If any of my numbers divisible by 2 should give me 0 remainder. Okay, I shouldn't get 1. Otherwise, this is an odd number. Right, hit enter. These are the evens. Now I want, if you do evens, if you will print evens, that's nothing. It actually shows you that, yeah, 2, 4, 6, 8, 10, but we want to print them. This is just a memory representation. Okay, this is a memory representation. So we can use the for each loop that we have seen earlier. For each var n or x or whatever, the iterator, var x in evens, I will console.write, like so, I will console.write line dat x. Okay, 2, 4, 6, 8, 10. It has printed the even numbers properly. This is what where does. Okay, the enumerable, by the way, it might be a mystery for some of you. The enumerable, this provides a helper method for working with collections. So if you want range, you cannot use it without enumerable. You cannot write simply var numbers equal to range 1, comma 10. You need enumerable.range. We have seen this before, and we said that this is called the lambda arrow. It's an anonymous function, it doesn't have a name, and gets things done only on one line. Lambda exists in a lot of programming languages, in Python, in JavaScript, in Rust, in Haskell, in a lot of programming languages. Let me also show you something called projections. And let's take numbers and let's use now keyword select instead of where. Okay, we want the number, every number, to be multiplied by itself. Okay, so we're going to open close paren. And inside here, I'm going to take an x as an input and I want to return x multiplied by itself. Okay, makes sense. So this is the squares method. So the select actually selects every number in the numbers range and multiplies it by itself. In other words, it transforms every value to be squared. So we can do exactly the same thing that we have done with the for each when we have printed or console.writeLine all of the even numbers. We can do the same thing for each var I in squares in this case, right? And we'll do console.writeLine and we want to print the I. Okay, and there you go. 1, 4, 9, 16, 25, and so on. By the way, you can do something very nice in LINQ. You can do ordering. Okay, ordering from the biggest to smallest, or I mean from the largest to smallest, or from smallest to largest. So you have done what? You have filtered, you have done projection, now we're doing ordering. So let's say, for instance, that I want to have this, just maximize a bit, a variable called sorted. Sorted in this case is equal to the numbers range, right, from 1 to 10. And I will access a method called order by descending, right? And I will take every x and I will return every x. But in this case, it's ordered by descending. It's in a descending order. So that's the sorted. Now we can again do for each loop var n in sorted. And we're going to console.writeLine and we're going to print each n, each number. And there you go, from 10 to 1. Okay, often these operations don't go separately, they are chained together. So we have what we call chaining in LINQ. So chaining means that you take some data set, you filter it, you sort it, you project it, and so on. You chain operations together. So let's see how we can So let's see how we can do that. Let's have a result variable, and that's equal to numbers. And we're going to say here where x as an input to return the x modulo 2, okay, equal to 0, dot select, then I will take again the x, and I will return x multiplied by x, and finally order by descending. I will not do ascending because that's the default, right? And again, I'm going to take x and I will return x. Okay, hit enter. So again, I'm going to use for each loop var n in result. Okay, and we're going to console dot write line that. That's n. Okay, and there you go. 100, 64, 36, 16, and 14. Now let's talk very quickly about classes and OOP, or object-oriented programming. I will not give you I will not explain to you everything about OOP in these few minutes. Plus I would expect that you understand what object-oriented programming is. But basically, this is a programming paradigm or style, because I don't know why the word paradigm scares people. Paradigm means style, guys. So this is a programming style based around objects. So everything is an object. Classes, which is an upper set, which is the, a blueprint, a map from which we create smaller objects, and also something called reusable structures. And this is a very important idea in OOP, a reusable structure. You don't repeat your code, you have it once and you use it multiple times. So that's what meant by reusable. So objects, classes, and reusable structures constitute everything in OOP. So let me give you an example. We can have a user class. Okay, and always start, by convention, start your class with U capital. I honestly like to do like this to differentiate, but whatever. That's your user class, and inside it you can have different attributes and methods. So for example, a user is a person, right? So a person can have a name, can have an address, phone number. These are attributes, but also he can walk, he can run, he can draw, he can program, he can, whatever. These are methods or actions that he can do. So every class in every class we should have the, if you will, the prototype for that user, from which we instantiate different objects. We create different instances or objects from that main user class. Okay, so that's going to be a public name, and public of course means that it's accessible from other parts of your application and not private. So public, and of course the name is a string, and inside we can have two methods, get and set. To get, which means to read the name, to set, which means to put the name, to insert the name. So to get the name and to set the name, right? Okay, that is pretty clear. Also, we can have public int age, that is also have that's also going to have get and set. All right, and that's pretty much it. This is our user. Of course, if you will type user like that, it's going to tell you user is a type which is not valid in the given context. You cannot just type user. We need to instantiate objects from that user, from that blueprint, from that class. Let me create the first object, which is going to be user1 equal to, take a look, new user. We have seen you. Where we have seen you, where you create new list, for example, right? We have done new dictionary, You remember, we said that we are actually instantiating this class by creating different objects, different variables. Everything is an object here. So from that new user, we want to set those attributes, those fields, if you will. So we can have here Joe or John Doe as name. He can have an age, and we cannot do more than this because in the blueprint we have only mentioned that we need to have a name and an age. You cannot continue putting here email, phone number, and so on. Okay, so let's shut this, and that is our user 1. Now, submission number 17.user, age 30, name John Doe. This is only the location in the memory. It tells you that we have a username from user class with age 30 and name John Doe. Now, there's something really cool in C#, which is the records, and a record is a lightweight data-focused type. If you want to create a record, you type record, and the name of your record, we have here a person, could be animal, could be alien, could be whatever. String of a name and int of age. Okay, so this is your record. As I said, this is very good for immutable data modeling. And immutable means you cannot mutate the value, you cannot modify or change. Now we want to create an object, a real record. So let's have var person equal to new, exactly the same like you would do with in OOP, new person, and then you're going to set those names. Back, for example, and 30 years of age. That's not my real age, by the way. Right, so that's the person. Again, this is not a very good representation. You can access the attribute inside by saying person.name, person.age, right? So this creates a record instance and access its name and age properties. All right, guys, time is running. And the last thing that I want to show you here is pattern matching. So pattern matching is one of the most powerful modern features in C#. It basically allows you to check data types, extract values, apply conditions, and branch logic cleanly. All that in a very compact and clean syntax. There's a data type in C# I forgot to mention called object. The data type object is the base type of everything in C#. And we can have here a variable called value, and let's give it value of 42, for example. That means that this value here could contain an integer, could contain a string, could contain a class, null, basically anything. All right. So now we need a way to inspect what is actually inside it. That's where pattern matching comes in. Let's have a result variable equal to value, and we're going to use switch. And of course, switch, like in any programming language, it's a cleaner way to do if else. So we're going to see here if the int n, when n is more than 0, in this case, I want to print positive number. String s to return with the $, and I'm going to pass the string. You remember the string interpolation? That's what we're doing here. All right. So if string, I'm going to pass the string. And if the value is null, I want to print null. I've actually written equal in the null part, so I apologize for that. So that is basically it. You will hit enter. Now you have your result. And again, of course, we can use the foreach to check out var x in result. And we're going to see what we will have. Console.write line, and we want to print that iterator. Do like this, and there you go. The last thing I promise I will show you in this tutorial is the nullable types. The nullable types is very specific to C# as of my knowledge. Maybe it exists in other languages like Java, I don't know. But simply the nullable types are very useful, and we use the question mark to say that the variable is allowed to contain null. So one very important thing I wanted to mention here, that null is not equal to 0. Okay? Null means that there is no value. Null means that no value. No value is not equal to 0 because 0 itself is a value. So nullable types use this question mark, and this question mark means that the variable is allowed to contain null. So basically in your application you want to check out if one side of your equation contains null or not. So you can do like the following: string with question mark. In this case the nickname is null. Also, there is something called the null coalescing. I'm not sure if I'm pronouncing it properly or not. Coalescing, right? So null coalescing uses actually double question mark. The double question mark actually is the null coalescing operator. It uses the left value if it exists, otherwise use the right value. So let me show you an example. If you do console.writeLine and you want to print the nickname, which has a value of null, and you're going to use the null coalescing operator, double question mark, otherwise anonymous. So it's going to actually check if the value of nickname is equal to none. In this case, we're going to write anonymous. Uncomment this line, hit enter, and anonymous. Why? Because the nickname is null. And I will see you in the next time. Till then, stay safe and be well.